All right, the second section of our kind of review chapter here is going to talk about linear models and rates of change. So really just a lot of stuff with lines and slopes. So we're going to just remember how to find the slope of a line passing through 2 points, writing an equation of a line given a point and a slope, interpret slope as a ratio or as a rate in real life application, sketch the graph of a linear equation in slope-intercept form, and then write equations of lines that are parallel or perpendicular to a given line. So just a reminder, the slope of a line is your rise over your run. Remember, it's the change in y value over the change in x value given 2 points. So that formal definition is your change in y over change in x. If you haven't seen the notation before, this triangle with the y, that's your delta. So that's delta y over delta x, which means change in y over change in x. Or your y2 minus y1 over x2 minus x1. And remember, you just use the m to represent the slope. So a couple forms for lines. What we'll find this year as we get more into the calculus, we're going to use point slope form probably more than anything, which is your y minus y1 equals m times x minus x1, where the x1 and the y1 are the point that's given to you, and the m is the slope. And so in this one, when you're writing the equation for your line, this y and this x aren't substituted in for. It's just the x1 and the y1. And then we have slope-intercept form. The y equals mx plus b. Again, remember the m is the slope and the b is your y-intercept. So in our first example, finding an equation of a line that has a slope of 3, so they're giving us the slope, which is your m, and it passes through the point, and they're also giving us a point. So they're giving us an x1 and a y1. And so if they're giving you a point and a slope, it probably makes most sense to use point slope form. So we're going to use the y minus y1 equals m times x minus x1. So if we use the substitution, we would have y plus 2 equals 3 times x minus 1. And then it asks us to sketch the line. So in order to sketch this, we can do it just from the point and the slope we were given, or some of you will probably want to do it from slope-intercept form, where we're distributing that 3 and then subtracting 2. So we would get 3x minus 5. So some of you, that will be an easier way to look at it. And then if we were to sketch this graph, you have your axes, and our y-intercept is -5. And then our slope is 3. So we could rise 3 and run 1. And then you could sketch the line that goes between those 2 points. So then going into the next slide, the ratios and rates of change. Just remember that if they ask you for a ratio or if they ask you for a rate of change, they're really just asking you to find the slope, right? So a ratio or a rate of change really has that same meaning as slope. If x and y axes have the same unit of measure, then the slope doesn't have any units and it's a ratio. If the x and y axes have different units of measure, then we're going to have a rate of change. So that would be if you have like a time and a distance graph, you might have like miles per hour would be your rate of change. And then when we're talking about this in terms of calculus, you'll have applications that involve both. So you have to be aware of those smaller details as you're going through these problems. So this next example, if we're using slope as a ratio, it says the maximum recommended slope of a wheelchair ramp is 1/12. That means your rise is going to be 1 and your run is going to be 12. And it says a business installs a wheelchair ramp that rises to a height of 22 inches over a length of 24 feet, as shown in the figure. Is the ramp steeper than recommended? So hopefully the first thing that you noticed is that the height they give you in inches. Oops, we don't want to do that. The height is in inches, but the length is in feet. So obviously we need to convert inches to feet or feet to inches. And to make it so we probably don't have decimals, we probably want to convert 24 feet into inches. So 24 feet, we would have 24 times 12, which would give us 288 inches. And so if we set up the ratio of the rise over the run, right, we know that the rise to run is 22 inches over 288 inches, which if you were to calculate that as a decimal is 0.076. Okay. The recommended wheelchair ramp shouldn't be any more steep than 1/12. So if you think about what 1/12 is as a decimal, 1/12 as a decimal is 0.083. So when you're looking at those ratios, this is really saying it's rising 0.076 inches for every 1 inch that it runs. The recommendation is that it has to be less than the 0.083. So the question, is it steeper than recommended? No, it's not steeper than recommended. It should work for being a good wheelchair ramp. So in example 3, it says the population of Utah was about 2,427,000 in 2005 and 3,161,000 in 2018. Find the average rate of change of population over this 13-year period. What will the population be in 2025, assuming it's still continuing at that rate? So for this rate of change, we want to look at the change in population over the change in years. So to find the change in population, we're going to take our ending population. In a way, we're treating this 3 million like our Y1 and this 2 million like our Y2, or I guess vice versa. So we're going to take 3,161,000 and subtract 2,427,000 and put that over our change in years, which would be the change from 2018 back to 2005. And so if we calculate that, we get 734,000 people. 2018 minus 2005 is 13. So it's changing by 734,000 every 13 years. So what we're going to want to do then is take that 734,000 and divide it by 13, which gives us the approximate change of 56,462 people per year. Right, so that's our rate of change. But then the second part asks us, assuming that the population continues to increase, right, what is the population in 2025? So what you're probably going to want to do is actually calculate like a slope-intercept form. So where you have your y equals mx plus b, right? We're going to assume that this right here, we're just going to say if this is our starting point, so if we're at 0 there to start, we would have then to solve for how many people, we would take our slope, which is 56,462, multiply that by 7, because 7 is the number of years between 2018 and 2005. That's like your x value. And then add b. So if that was our starting value, that was our 3,161,000. And so if we were to calculate that, we would get that we're at approximately 3,556,234 people. So then moving into just a reminder of sketching lines. When we're in slope-intercept form, we've already sketched one like this, but probably the quickest way is you need to draw your axes. We have a y-intercept of 1 and a slope of 2, so we would rise 2, run 1, and then you can draw your line between those 2 points. Okay? So then the next one that we get to here is the y equals 2, and if y equals 2, that means we don't have any x's. So if y equals 2, every value on our line, y has to be 2. So whenever you have that y equals, you have a horizontal line. If you have x equals, you're going to have a vertical line. And then this last equation is in standard form or general form. So the easiest way to graph this is let's put it into our ax plus by equals c form, and we're going to use intercepts to graph. So if we did that, we would have x plus 3y equals 6. If we were graphing our x-intercept, we would plug a 0 in for y. So if you were to plug a 0 in for y, you find out that your x-intercept is 6. So on your x-axis, you're going to plot a point at 6. Your y-intercept would be when you plug a 0 in for x. And if you were to plug a 0 in for x, you would be then just left solve 3y equals 6. So your y-intercept would be at 2. So then you would sketch a point at 2. And now you have your 2 points, and you can sketch the line that goes through those 2 points. So here's your slide just with your equations that we've talked about. The general form, when you're working with general form, if you have to graph, you're probably going to use your x and your y intercepts, right? Moving the c to the other side. Remember, vertical lines are just your x equals equation. Horizontal lines are your y equals equation. And then we have the slope intercept and the point slope that we've worked with earlier in the section. So then the last thing that we need to talk about in this section is the parallel and perpendicular lines. Just the reminder that parallel lines have the same slope. Right here, parallel lines. Oops, that's your eraser. Parallel lines, the slopes are equal. Perpendicular lines, the slopes are, they say negative reciprocals, but I usually think about it as an opposite reciprocal. Because if the slope is negative, then the perpendicular line will have a positive slope. So this last example, finding parallel and perpendicular lines, we have 2 parts to it. The first one, we have general form of an equation. Find general form. So general form, remember, if you go back, is your ax plus by plus c equals 0. So we need to put it in that form. In general form, your a has to be a whole number. So it can't be negative, and it needs to not be a fraction. So we might have to clear the decimal. So first we have a line passes through the point 2, -1, and we're going to be parallel to this equation. So if we're parallel, the first thing that we should probably do is figure out, oops, we don't want to do that, figure out what the slope is. So let's put it in slope-intercept form. So subtract the 2x, divide by 3, we get 2/3 x minus 5/3. So what they're telling us is we're going to use the point, and then we're going to use the slope of 2/3, right, if our lines are parallel. So for part A, if we use point slope form, we'll have y plus 1 equals 2/3 times x minus 2. If we distribute 2/3, we get y plus 1 equals 2/3 x minus 4/3. Remember that the number in front of the x needs to be a whole number. So since it's 2/3, let's clear the fraction and multiply everything by 3. So we get 3y plus 3 equals 2x minus 4. If we move everything over to the left, we get negative 2x plus 3y plus 7 equals 0, but we need this a value to be positive, so you need to multiply everything by a negative, so we would get 2x minus 3y minus 7 equals 0. For the second part, when we're dealing with perpendicular, remember perpendicular is opposite reciprocal. So for part B, we're still going to use the point 2, negative 1, but now we're going to use the opposite reciprocal slope would be negative 3 halves. So if we write our equation of y plus 1 equals negative 3 halves times x minus 2, so we would get y plus 1 equals negative 3 halves x plus 3 when we distribute that 3 halves. Let's clear the fraction. So multiply everything by 2. So we get 2y plus 2 equals negative 3x plus 6. And then when we move everything over to the left, we get 3x plus 2y minus 4 equals 0, and that would be our general form.